Good morning, family. Greetings and salutations to all you Autobots. Who might burn? They get burned. Now it's all eczema. Anyways, it's good to see you guys. You guys in the back, get your feet down from the chairs. Thank you. Heads up. And nobody bury your heads in your arms. Everybody wakey wakies. Just like class. Hold on. Oh, it's you guys. Good to see you. And welcome to the word of the day, brought to you by our proud sponsor, CDX Automotive Books. And now a reading from the Gospel according to Glossary. Ooh, we've got a good one today. Accumulator. I'm sure there's a joke in there somewhere. Accumulator. You accumulate now? No, I'm an accumulator. Anyways, heating and cooling system accumulator. A device placed between the evaporator and the compressor to collect liquid refrigerant and prevent it from entering the compressor. So a compressor needs to work on gaseous refrigerant only. If the refrigerant, the R134A, which is what it used to be in R12, what it has been, and whatever new formulation that the industry standards dictate, but I'll just speak in the one that I was most familiar with. This is R134A. The refrigerant, as it's used in your car, is supposed to be a gas. It gets circulated from the compressor pump out through the high pressure side, and then, as you guys know, when you compress something, you heat it up. So once you compress the gas out of the compressor, it heats up a little bit, and you need to bring it through a heat exchange. We'll cover air conditioning later, the condenser side. One of the things that can happen if it's really cool outside is that as the air conditioning R134A refrigerant flows through the lines and cools off after being compressed and then brought through what looks like a radiator. Sometimes it cools itself off a little too effectively and it starts to condense. Now, condensation inside, and also especially if there's any kind of super minute cracks or leaks in the system, sometimes moisture gets in, just normal water moisture. And water moisture is very detrimental to air conditioning systems, either from the inside or the outside. On the outside, I know you guys have definitely seen when the air conditioning system's been running too long and it's too humid out, and you can actually develop ice on the condenser, on the accumulator, or ice gets developed on the fins of the radiator and on the hoses leading to and from the compressor. This ice buildup actually detracts from the ability for the air refrigerant from heating and cooling as it needs to in the system in order to provide the refrigerant effect. So an accumulator is a device placed between the evaporator and the compressor to collect liquid refrigerant and to not allow liquid refrigerant to go through the compressor. Instead, it allows the condensate to re-vaporize and join the normal routing of gases throughout the refrigerant cycle without becoming liquid, which doesn't work great. in order to work really well, refrigerant needs to remain a gas. So that's it. An accumulator is that device. It accumulates the condensation, allows it to settle down, and then re-evaporate. That's it. We also have there are two other accumulators. So a car can have a possibility of 3 or even 4 accumulators. There's one for an accumulator can be used in a fuel line system. Can be here an accumulator for a manual transmission. I'll read this. A device used to reduce the speed of clutch or band application to help prevent harsh shifting. In this regard, the accumulator provides. It's been a while since I touched one too. Usually, if an accumulator goes and you get bad shifts and grinds between the gears, you just toss the tranny. You don't rebuild it off of a bad accumulator. It's an earlier device, and now with the new double clutch systems, I don't see them. Maybe King can tell us what they actually were big in. I myself have not seen very many of these. Yeah, when they talk about a speed of the clutch or band. So transmissions used to have something called a Bendix. Bendix, excuse me, Bendix. And it was basically like a leaf spring of a spring inside the transmission to provide tension for the clutch and the clutch plate. And if you popped the Bendix, you can actually reach underneath with a wrench and screwdriver and wiggle the spring back into place to provide tension against the pressure plate. Ooh, an alarm. It's almost noon. Okay, and it's just a device used to reduce the speed of the clutch. So when you're shifting from high RPM into the next gear, and it's really a lower gear, like a deep third to fourth shift, where you wound third out and you're like 9,000 RPM, and you shift into fourth, and it's a real low fourth, or a tall fourth, I should say. The accumulator slows down the clutch the clutch assembly, so that it modulates. There you go. It modulates the speed between the engine and the clutch assembly, so that the shifting isn't harsh and grabby. That's it. That's all it does. And last but not least, the one I know most about is the brakes accumulator. So it's a storage container that holds pressurized brake fluid. You will definitively find brake accumulators inside of ABS systems. It is actually how ABS systems work. Inside of your ABS system, you'll have an incredibly small micro pump. This micro pump takes brake fluid and pressurizes it in an accumulator. It to the tune of, as I'm sitting here, I think it's several thousand PSI. It's quite substantial. And so it uses this accumulator, this reservoir of pressurized brake fluid, so that when you're braking and then you have an emergency brake, the system isn't dependent on what kind of brake pressure you bring to bear on the brake pedals. The ABS system itself takes over and starts activating the different discs or drum brakes, in this case, discs on the front, and it really rapid fires 8, 9, 10, 20 times a second. It grabs and lets go of the brakes to provide anti-lock braking service for your car. And it can't possibly do that with just your foot pedal pressure. It has to have its own accumulated bottle of pressurized brake fluid that it could shunt through all the different separate brake lines. Each brake line is front left, front right, rear left, rear right, or driver front, passenger front. and it would fire off and put pressure in each specific line, depending on which line has traction, which has lost traction. If it lost the traction starting to slide, means the brake has grabbed on really hard and the tire has now started to skid. The tone ring, because it's not going around and giving the wheel speed sensor any moving signal where it was just getting it, the wheel speed sensor goes, we've locked up. Hey, let go. And the accumulator and the attendant solenoids and all the electronics depressurize that line. The brake opens up. The wheel starts to spin. The tire spins and develops friction against the road rather than sliding. It is now rolling and is allowed, and it allows it to friction against the road surface, to which now the tone ring is spinning again, and the small wheel speed sensor senses that the wheel's turning again, and it measures the wheel speed of its tire with the other tires and saying, okay, it's back up to speed, it's in good contact with the road, grab the brake again on this side. And so the signal goes out, the electronic brake control system and the ABS system say, okay, wheels back on traction, hit it again with some pressurized brake fluid, close that caliper, let's get it braking again. And so it adds pressure until the brakes engage, and it slows the vehicle down even more, and it applies more and more pressure until wheel slide occurs again, the loss of friction, where the wheel and tires slide over whatever surface you're on. And it's this pulsation of pulses in the brake line that the accumulator provides pressurized brake fluid for. So that's the brake accumulator. What else can we talk about today? Ackerman angle. I know King loves talking about the suspension of Ackerman angle. We'll read that one. The angle the steering arms make within the steering axis projected toward the center of the rear axle. And then there's the Ackerman principle. The geometric alignment of linkages in a vehicle's steering such that the wheels on the inside of a turn are able to move in a different circle radius than the wheels on the outside. So first we'll talk about Ackerman principle. We know that if we have 4 tires, 2 up front, 2 in the back, and if the rear tires don't steer, this is very important because 4-wheel steering does exist, and that's an entirely separate can of bees, or whatever the saying is, can of worms. But let's just say it's a standard Honda Civic, right? Front wheel drive. The rear tires stay set. They have a big long bar between them, so their track is set. They rotate independently, so we're not worried about how the revolutions of each tire get counted on its wheel track. But we're talking about the front tires. So you're driving down the road, and those tires, you'll notice the inner tire pulls harder. It isn't equal. So if I go 15 degrees, the inner tire will actually be a little bit more than 15 degrees because its angle of rotation as it goes around, like if you scribed the angle of it going around a corner, it's actually tighter than the wheel along the outside. So it needs to have a tighter angle. And this angle is completely encompassed within the Ackerman principle. It's the geometric alignment of the wheels and tires. The Ackerman angle itself is the angle the steering arms make with the steering axis projected towards the center of the rear axle. So if you take where the steering arms connect and how they are as attached, I think, on the knuckles, and you draw a line, that line becomes a V, like you do left front and right front. they angle in and they cross each other. They should be crossing each other, if I remember correctly, at the rear differential, or very close to the rear differential. And that angle then provides, because the wheels are straight, but the angle between the center line and the knuckle connection point where the steering arms connect, those two lines from the center point to the knuckle, and you draw that line, they're going to intersect at the rear differential. So that means is that when the tires turn, they don't turn an equal amount. They turn with a bias to the inside, so that the inside tire gets pulled in more into the turn angle. And that's the Ackerman angle. There's some awesome videos. I think I might post a couple in the comments section about Ackerman angle and the Ackerman principle. But for now, that's all we can do. We covered accumulator, the 3 or 4 different types of accumulators we can have. There's an accumulator in the AC system. There's an accumulator in your manual transmission. I think those are older ones. Brakes accumulator in the ABS system. There's also an accumulator. They used to run, I know a smog system had an accumulator. Late 70s Pontiacs, like Firebirds, they had smog system, and it had an accessory drive belt-driven smog pump. It was nothing more than an air. It's actually a compressor, but for every air that it compresses, it has to pull vacuum, has to suck in air in order to pressurize it. So it was a big sucking in air pump, and that air pump would pull exhaust gases in and reroute it in through the intake manifold. So it was rebreathing exhaust gases to get a cleaner burn. And if I remember correctly, some of the earlier models of this type of recirculatory exhaust management had an accumulator attached to the pump, which would help store air at some point. One of the first things you throw away when you want to make power is you get rid of exhaust gas recirculation systems, EGR. The best way to save the environment is not by scrubbing exhaust air. That's not it. It's by getting the cleanest, most perfect burn out of your combustion process. That's the key to efficiency and reduced emissions. Making sure your cam profile presents an efficient use at lower RPMs. Things like adjustable valves or the free valve system that Koenigsegg's coming out with, combined with direct injection. These are the ways that you're supposed to really clean up a vehicle's exhaust emissions, not smog pumps and smog accumulators that reroute and pressurize exhaust gases back into the intake manifold. It's all Band-Aids at that point. It's no good. That'll do it for today. Words of the day. I hope everyone enjoys this TGIF. Oh, I forgot to do that part. Today is May 15th, 2020, 12:06 p.m. Meaning right after lunchtime. I haven't had breakfast or lunch yet. I'm hungry. I hope all of you go get something to eat. I am going to go deposit some monies and go get something to eat. I'll see everybody in an hour.